All right, in these examples, we're going to learn how to evaluate logarithms. And, just being honest there, I showed you on the calculator, if you've watched the last videos, how to do that using the calculator. So this can all be done in the calculator pretty quickly. But the challenge for you guys is to do it by hand first and see if you're able to get it in the calculator, because you want to know what the meaning of a logarithm is. So that's what our goal is for these two examples. And you can check a couple answers in your calculator if you'd like to, but I really want you to try these on your own. So on this example here, we want to evaluate log base 2 of 32. So we want to start with by saying, maybe we can set it equal to x, and we can rewrite it as an exponential function. So we would identify the base, raise it to the x power, and we come back and set it equal to the number in the log. And so our goal here is to figure out what number could I raise 2 to get 32. Now, if you need a calculator for that, that's understandable. We can kind of guess and check if you don't know. 2 to the third power. Well, that's only 8. So let's try 4. And 5. In other words, 2 times 2 times 2 times 2 times 2 is equal to 32. So the answer to this question is 5. X is going to be 5 in this case. So log base 2 of 32 is 5. 2 to the 5th power is equal to 32. So that's kind of the idea behind here. Now, as a refresher, if you're checking or just are wanting to know how to evaluate in the calculator, you in Desmos can simply type the word log, and you could do shift, hold down shift and hit the minus key next to the 0. And you can put that 2 in here, put a right arrow, and in parentheses, you can put 32, and that will give you 5. So the answer is there for those that need it, but challenge yourself to try these on your own. That's the last one I'll check in the calculator. You can do the rest if you'd like. So for part B, I'll set them equal to x. I'm going to rewrite it. 1/2 raised to the x power is equal to 1/8. Remember, this is your base. Come out, go back. So 1/2 to what power is equal to 8? What we can do on this problem is think about the 2 in the base and the 8 in this base, and seeing what can I raise 2 to get to 8, because that's really what it is. 1/2 times 1/2. If you multiply fractions, you're just multiplying the numerators and the denominators together. So it's going to be 1 and 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So it's going to be 1/8 if I multiply 1/2 times 1/2 times 1/2. Well, there's 3 of them. So that's going to be a third power. 1/2 to the third power is equal to 1/8. So that should be 3. Log of 100, no base written. So remember what the default base is? If it's not there, it's 10. So that's another way of saying 10 to the x power is equal to 100. What can I raise 10 to get to 100? Well, 10 times 10 is 100. So 10 squared equals 100. So that x value is going to be 2. So log of 100 is 2. Example 4 has similar questions. They're a little bit trickier. So let's set up letter A. I'm going to set that equal to x. I'm going to say 8 to the x power equals 32. Now what 8, you can't raise 8 to a power to get 32. I could say 8 to the second power, that's 64. 8 to the first power is 8. So it's going to be some number between 1 and 2. Maybe it's 1.5 or 1.6, 0.7. 1.7 is a little bit too high. 1.6 is too low. So how do we get that exact number? So in this case, we have to do a little bit of trickery here. We got to look at the 8 and 32 and break them down. So let's look at the 8. Is there a number that I can raise 8 to? So in other words, what number can I raise? Let me rephrase that. I want to find a common base that goes into 8 and 32. So what number to a power can get me 8? And what same number to a different power is going to get me 32? So let's think about breaking 8 down. If I break that down, I can do like 4 times 2, and the 4 could be breaking down into 2 times 2. So I can raise 2 to the third power to get 8, right? So let's break down 32. 32 is going to be 2 and 16. 16 is 2 and 8. 8's 2 and 4. 4 is 2 and 2. Well, how many 2's is that? 1, 2, 3, 4, 5. 2 to the fifth power equals 32. So we can actually rewrite this as, instead of 8 to the x power, we can say 2 to the third power. So 8 to the x power is equivalent to saying 2 cubed to the x power. Does that make sense? Because 2 cubed is equal to 8. So 8 to the x power is 2 cubed to the x power. And 32 is going to be written as 2 to the fifth power. So since 32 is 2 to the fifth power, we can actually solve this equation. So what this equation is going to look like, and I'm going to write this on a clean sheet of paper so it's a little bit easier to digest. So we'll have 8 to the x equals 32. 8 to the x became 2 to the third to the x power. 32 became 2 to the fifth power. From rules of exponents, you remember that you multiply exponents that are being raised to a power. So it's going to be 2 to the 3x power equals 2 to the fifth. Once you have a common base, those will actually cancel out. So your equation is just going to be 3x equals 5. And so the value of x is going to be 5 divided by 3. And that's not going to reduce, but 5/3 is your exact answer. If you want to get the decimal, divide those two numbers, and what will you get? Well, 5 divided by 3 is 1.66666 repeating. So if I actually went back in here and said 1.666666666, notice that'll get you closer and closer to 32. And that's our goal. So our answer is actually going to be 5/3 or 1.6 repeating. That's a lot to do in some of these. They're not always going to be decimals like that, but in this case here, log base 8 of 32 is 5/3 or about 1.6 repeating. And I'm all over the place here, so hopefully you're able to follow along with that. And we would want to check that. I would do it. I would put that in the calculator to check. So I would do log underscore shift minus 8 parentheses 32, and indeed it's going to give you 1.6 repeating. All right, how about this one here? Log base 4 of 1/64. So we're going to set that equal to x as well. We're going to say 4 to the x power equals 1/64. And I have a fraction here. So in order to actually make that not a fraction, what we can involve negative exponents. If I flip that, so 1/64, well, first let me break down 4. Can I raise 4 to a power to get me positive 64. Is that possible? Well, 4 times 4 is 16. And then 16 times 4 is going to be 64. So I know that 4 to the third power is equal to 64. So what I'll do first is I'll say 4 to the x power equals 1 over 4 to the third power. Properties of exponents. If I flip the fraction and I say 4 to the negative third, 4 to the negative third is actually equivalent to 1 over 4 thirds, because when you go to the other side of the fraction, it changes the sign of the exponent. Notice that I now have the same base. Well, I can cancel those bases out, and it'll tell me x is equal to negative 3. So the answer log of base 4 of 1 over 64 should be negative 3. You can put that in the calculator. Letter C has an exponent in the log. So I'm going to set that equal to x. This one's actually, I would leave that as 2 to the 5th power. You don't have to evaluate that because you're going to see real quickly what happens. If I raise that 2 to the x power, and then I set it equal to what's in here, you notice that we already have a base we can cancel out. So in this case, x is going to equal 5. So that's actually pretty easy. So the answer of that is 5. All right, we got a few to try on your own. I want you to convert these to, convert to exponential form and evaluate them. Check in your calculator if you need to. Pause the video and try it on your own, and we'll reveal the answers afterward. Okay, I have these worked out, so if you haven't finished working them out, make sure you click the pause button and try them first, and then you can check with me or you check in the calculator if you want. Question number 1, if you're ready. Log base 4 of 64 should be 3. Here's the work for it. This 4 to the third power is going to get you 64, so that exponent will be 3. Number 2 should be 1.5 or 3 over 2. You can break the 4 and the 8 down to a base of 2, so 4 is 2 squared, 8 is 2 to the third power, and that 2 with that x, 4 is 2 to the second power, so you're going to multiply the 2x, and that 3 will just stay there. Those will cancel, 2x equals 3. And then divide the 3 by the 2, and you'll get your answer 1.5 or 3 over 2. Okay, question 3. 1/3 to the third power. If you multiply 1/3 times itself 3 times, you're going to get 1 over 27. So that's 3. And then the last one, this is where the negative exponent's going to come in, because 25 is the same as 5 squared. But you got to bring it up here and make it 5 to the negative 2. So 5 to the x power is equal to 5 to the negative 2. So x is going to be negative 2. So hopefully you're able to get those. All right, see you next video.